All right, lesson 1-8, mean value theorem. Today's date is Thursday, September 3rd, 2020. Our objective today, Chris, go for it.
What does it say? Recognize where MVT can be used and then use it to solve problems.
There it is, thank you. An MVT, of course, is in the title, mean value theorem. I said it already, but lesson 1-6 and 1-7 are the two halves of the mean value theorem. And in this lesson 1-8, we're putting those halves together for that perfect understanding, hopefully. So let's review differentiable. This is just from last night's homework. First of all, I need to figure out what the instantaneous rates of change are for the points below. So you do this as well. Go ahead and make a line for each of the instantaneous rates of change. So you're going to have a tangent line through there and then through the rest of them. Make sure they have the approximate correct slopes in your notes. And my writing tablet is not working again. All right.
Oh boy.
Come on, writing tablet. Okay, it's just I've realized that this thing is 7 years old, and that's probably the reason why it's dying. And I've used it almost every day, school year wise, for those 7 years. All right, I guess I'll just type this in.
Whoa.
So this one right here is f1. So that's the slope of that line, f prime of 1. Is that slope positive, negative, 0, D and E? You only have those 4 choices. What is this first slope?
Positive.
Let's do thumbs, I think. You got it right, Chris. It is positive, but let's do thumbs. Positive, 0 is equal, negative, and then let's do a fist if it does not exist. Does that sound good? And everyone's been thumbs up. Yep, so it's positive, so we say it's greater than 0. And that middle point, this is going to be f of what? F prime of 2. What is that? 2 thumbs. Is that positive, 0?
Oh, wait. What's I don't know what 0 is again. So
0 is like in the middle, so you go.
Oh, okay, I got it. Sorry.
You're good. Okay. How do I say this thing? Someone say it out loud. Andrea, how do I pronounce this thing? We're talking about the slope. What do I type in here?
F.
Chris has it, but I'm waiting for Andrea to do it. Andrea?
Sorry.
Oh, F prime of 3.
F prime of 3. There it is. F prime of 3. And everyone do thumbs. F prime of 3 is, yes, you guys got it, negative. Cool. And then we have this point down here. This is going to be F prime of 5. Thumbs. F prime of 5.
I don't know.
0 from Fiona. Does not exist from Andrea. 0 from Chris. 0 from Teflon. Yeah, this one is a D and E. But now I'm waiting for a quiet raised hand. Tell me why it's not 0. Tell me why it is a D and E. Yeah, Fiona.
Because it's a sharp corner.
Sharp corner. Those one of the 3 things that will make U not exist. So let's go ahead and list those 3 things again. So any one of them. Sharp corner is one of them, right? What's another one?
A hole.
A hole, which is a type of discontinuity. So if I sharp corner, discontinuity, or vertical tangent.
Oh.
Okay, let's do those again. Sharp corner, discontinuity, vertical tangent. You guys got them?
Yes.
All
yes.
right. Give me the 4 types of discontinuities. These are the things that we have to have memorized now. 4 types of discontinuities. Go. Shout them out if you know them.
Sharp corners.
No, that's not discontinuity, because if it's sharp corner, I can still hold my pencil down. That's still okay.
Wait, what?
There's
Oh.
4 types of discontinuities.
Hole, gap, and I forgot the third.
There's 4 of them. Holes, gaps,
Wasn't it vertical asymptote, something like that?
vertical asymptote is one of them, and And-
an end? What about an end?
exactly, yep. Perfect. Okay, so we'll be reviewing these more and more. Let's go ahead and talk about f prime of 7. F prime of 7. Do your thumbs is the instantaneous rate there. Positive, 0, negative, DNE. Again, DNE from Fiona, DNE from Andrea, and it is in fact DNE. It does not exist. And finally, f prime of 8. Again, thumbs. F prime of 8 is positive from Fiona. I'm only seeing one person participate. 0 for Andrea. Looks like Fiona's changing it to DNE. Teflon, Chris, what do you guys think? What is the instantaneous?
Positive.
Positive from Chris. What about Teflon? This one's actually a DNE. But why?
Because it ends.
It's an end. Ends are discontinuous, and if it's discontinuous, you can't even be differentiable.
When I'm taking a test on this stuff.
Yes, in the very, very near future. 1-9 is a review lesson, and then we're just doing tests.
Oh, great.
I'll get you warmed up for the test because you can't retake the test, and they're kind of scary, but we will have, what are they called? Oh man, I'm blanking on the term, but we'll have self-checks. We'll have 4 self-checks where they're basically practice tests, and then we'll do an actual practice test, and then after that, we'll actually do the test, so make sure you really get it down just in the first round with all the pre-test, or not the pre-test. I just forgot it. Anyway, let me go ahead and pause sharing my screen because
Can I go to the bathroom?
no, this is super important.
I have to go.
Just go like during break.
What if I bring you with me to the bathroom?
Sure, just turn off your camera. When you go to the website, everyone's going to be doing this for part of your homework assignment tonight. You should, I guess I should have been doing it from the very beginning. But your homework assignment tonight, you're going to go to the website. You're going to scroll down here to AP Calculus, wherever that is. Come on, load computer. You come down here to AP Calculus. You're going to go to your Unit 1, Limits, Continuity, and Differentiability. Cannot say that word. You're going to come down here to the very bottom under everything for the speed sheet. The speed sheet is your homework tonight. After today, you have learned every single thing on the speed sheet. We're going to be just doing a little bit review tomorrow. Oh my God, why is this not loading? And then you're going to start doing the matching game. I'll do it really quickly. I'm trying to use my fingers. So limit as I go to plus or minus infinity, that is a horizontal asymptote. So I come down here, horizontal asymptote. This is your continuity test, match with continuity. IVT, that's the one that proves heights. MVT proves slopes, which is what we're learning today. Holes, gaps, ends, and EAs, those are types of discontinuities. Limit to infinity, top and bottom, you have to do magic fraction. So obviously it's not a good time, but you need to get these down really well. And let's go ahead and come back here to the notes. That is part of your homework assignment, even if I forget to say it. So mean value theorem. Let's actually do our new stuff for today. I'll let you guys copy this stuff down. All right, so mean value theorem. Let's start with 1-6, average rate of change. Oh my God, Ms. Taylor, please just, it's okay. Average rate of change is represented graphically with what? You guys will all shout out.
Something.
Something, yes. Graphically, it's represented by a line through those 2 points. So if I'm doing the average rate of change between my first point and second point, let's go ahead and just randomly assign them letters. Let's say letter A and letter B. The average rate of change between A and B is represented by a line. A line here, shunk. This line, I don't think I said it before, but it's called a secant line. So this line is called a secant line, just meaning that goes through the function at least twice, if not more than twice. Okay, so this is what the mean value theorem states. The mean value theorem states, look at that slope of the secant line. If I were to take a little chunk of it, or if I were to, even better yet, let's copy paste it. I have technology. I grab that line, Control C, Control V, or V. I'm gonna change it to a red line. Okay, so I have a second line, but it's the same exact line that I started with, so it has the same slope. We can all nod your heads. Yes, you just copied and pasted it. As long as I move it around like this, it's not changing the slope. It's always parallel, right? What the mean value theorem states is move this line somewhere else, and it will be tangent eventually at least one point in between here. Ready? And boom, it's tangent. See, it's tangent to this point over here. We don't know where it happens. The mean value theorem doesn't know where it happens. It just says, hey, I can move this secant line anywhere and it will eventually be tangent. It's saying that the slope of the tangent is going to be equal to the slope of that secant somewhere in this interval. And it might happen more than once. For example, like if I copy and paste this, I can have it happen. Let's move it up, 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 and boom, it happens right there also. It'll happen at least once. That's what mean value theorem states. Just move the secant line and I will have a point of tangency at least once. In this case, I have it twice. So that's mean value theorem, graphically. So the secant line, we moved it until it turned into a tangent line. This is now, we'll say tangent. Now tangent. Okay, so that's the graphical representation, which I wish some teacher had shown me because they started with this really confusing formula that looks like this down here. Okay, every single of our 3 theorems that we're learning in Unit 1 have a need. Let's see if you guys can remember the needs all the way back from 1-5. IVT, what do you need in order for IVT to be proven? Shout it out if you know it. Yeah, Fiona?
Continuous.
Continuous. Yeah, and then you, Stephanie, awesome, that's awesome. So continuous will prove IVT and IVT will prove heights. What about EVT? What does EVT need? It needs 2 things.
Closed and continuous.
Closed and continuous, and then here's MVT. MVT needs it to be only one thing, which is really 2 things if you're thinking about it. It's only one thing, it's differentiable. And the inner student in me is thinking, oh, Mr. Snell, thank you for letting me know how to figure out if a function is differentiable because now we know how to do MVT, right? That's the logic behind why I did all the stuff I did for the past few lessons, right? So if I'm differentiable, that means I don't have any of the following. I don't have any discontinuities. I don't have any holes, gaps, ends, or VAs. That means that I don't have any sharp corners. I don't have any vertical tangents. If all of those things are not there, then I'm differentiable. If I'm differentiable, MVT applies and it says that the slope of the secant line will at least be the slope of the tangent somewhere in the interval. So here is the definition of MVT. This is the one that's in textbooks. If my function is differentiable, then f prime of c is equal to this thing, f of b minus f of a all over b minus a. Does that right-hand portion of this formula right over here, does that look kind of familiar? Can you nod your heads one way or the other? No, it doesn't look familiar. Yes, it does look familiar. I got a tiny little head nod from 2, maybe Teflon. I just can't see her. I just see her ceiling. There you are. Okay, it is a head nod from her as well. Does anyone remember what that is? We've written it down before in AP Calculus. Quiet raise hand. Anyone have an idea? I said it would come back. It's already coming back. It's going to come back in like Unit 9 as well, or some later unit, but it's definitely coming back right now. Oh, okay. I'll write it down.
The average rate, isn't it?
Average rate, yep. Average rate of change. And technically it's the slope of the average rate of change. So I'm going to write down the whole thing. But good job, Teflon. Average rate of change. So the slope, or the, I can say the slope of, or you can say, I guess they're synonymous, the slope, or it's the average rate of change This is the blue line that I was talking about before. This is the secant line. This gray right here is the secant line if you're thinking of this graphically. And then we can move him. We don't know where this point C is, but we had one of them right here. We can say that point was C. And since we had two of them, I'll call that one C1. And maybe over here, this is going to be C2. There's at least one C in between this interval, between A and B, such that when I take the slope of the tangent line at that x-coordinate C, the slope of that tangent line is the same slope as the secant line. So I can come back here and can I grab some things? There we go. So I'll write down here that this is the slope of the tangent line. The slope of the tangent line. And obviously, it has to be somewhere in between A and B. And I'll just say at some point. At some point. We don't know what point. So we know that IVT needs continuous and it proves that it proves heights. EVT needs continuous and closed and it proves minimums and maximums. This needs differentiable and it proves, and you can underline it here, slopes. Everything that, like this is a slope, it proves slopes. So if there's one word that you know that MVT proves, it proves slopes. Slopes. Everything right here is a slope. So if you ever see anything with an F prime in it or anything that's talking about slopes or rates of change, you might be thinking in the back of your head, that sounds like MVT. If I need to prove something, I'm going to be using a theorem, and there's only one theorem in AP Calculus that we're going to be using with slopes, and it's MVT. All right, let's do two examples, and then we're done with the notes. And they're going to take a bit of room. Yell at me if I should stop here for a sec. No. All right, we're moving on. All right, I'll let you copy this down. In fact, I'm going to scroll out so that you can copy down all of these problems. Is this enough? Oh, just a little bit more. There we go. All right, and I'll pause. Okay, so let f be a differentiable function such that f of 3 is equal to 8 and f of 6 is equal to 17. That's all we've got. Okay, and then it's asking the question. Now we need to explain. It doesn't even tell us to find a value, but we need to explain why there has to be a value of c in between 3 and 6 such that f prime of c is equal to 3. That sounds like gibberish when I first look at it. Like, what the heck is going on there? A bunch of numbers happening here, some weird interval, f prime of c is equal to 3. How do I put all of these pieces together? So the first and most important thing that I'm looking at is this thing, f prime of c. That's talking about a slope. Whenever I'm talking about f prime of something, that is a slope. There's only one theorem that proves slopes, so automatically I'm thinking somehow I must be using MVT. Okay, so I'm just going to go ahead and write out the definition of MVT, and hopefully that will help me solve this. So I'm basically copy pasting this thing. I'm rewriting f prime of c is equal to blah, 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 blah. So f prime of c is equal to f of b minus f of a all over b minus a. And I want f prime of c equal to 3. And look, we have an f prime of c right there. So that means we can do a substitution. This is no longer f prime of c. That f prime of c is 3. So there's a substitution. I come down here for the next line. Let's do orange. That is now a 3 over there on the left-hand side. I'll pause for dramatic effect and make sure that you can think about this a little bit. All we do is replace it. Okay, but we don't know what f of b, f of a, like what is a and b? Anyone have an idea? What should we do with a and b? Fiona?
F of b, or it would be f of 6 minus f of 3.
Exactly, yeah. So you're saying that our b is going to be 6 and our a is 3?
Yeah.
Yeah, and then it comes from this interval right here. You can see that the very end of our interval, just like I had up in the picture up here, if I had, where was it? A is the far left, and then my title starts not working again. A is over on the left, B is over on the right, and then down here we see that A is over on the left, B is on the right. So no, please, if I unplug you and replug you in, can you please work? Not now, technology. Okay, I guess I'm typing. So down over here we have f of b, and b is 6. So f of 6 minus f of 3. And that's all going to be divided by b, which is 6 minus 3. I can do a quick line here just with my trackpad. Shork. And then we can figure out what that is. So I can't do an equal to because this is already an equation. So I'm going to come up here. Trackpad, don't fail me. So I still have on the left-hand side, I still have 3. Maybe I can make this size bigger. That'll help. So 3 is equal to, and then on the right-hand side, f of 6, we know f of 6, that's 17. Tells us right up there. And then so it'd be minus f of 3. F of 3 is 8, so minus 8. And that's all going to be divided by 6 minus 3 is all going to be divided by 3. I'll go ahead and do a line here. Shrink. (17 minus 8 is 9. So now I'm left with, come back here to the text tool, click black. Let's say 3 is equal to 9. And then on the bottom down here, I have divided by 3 still. And we can clearly see that 3 is equal to 3. We've proven it. Another way of saying this is if we never did the substitution, if we kept leaving this f prime of c, we would have eventually gotten to f prime of c is equal to 3. It's just a slight differentiation. I guess we could have just always rewritten f prime of c, f prime of c, f prime of c, and then now we finally see f prime of c is indeed equal to 3. But yeah, we've proven it. There's a little box down here because that's our proof. It's a pretty easy proof. Do a little box that's filled in. Done, proven. Let's try another one. Example 2. All right, and you've already copied this one down. So again, we're trying to find the average rate of change, or I guess it's slightly different. We are now trying to find the average rate of change of this g of x on the interval from 0 to 6. So kind of important there. Oh, it's working yet, yes. So from 0 to 6, that means we're starting here and we're ending there. I'm gonna go ahead and circle 0 and 6. And I'm asking now, does MVT guarantee that I will have a rate equal to the average rate of change? So what is the average rate of change? I guess we should find it, right? Saying equal to whatever that average rate of change is. So let's purely do this graphically. It's saying, does MVT apply in this case? So graphically what's happening is I'm going to go to the x coordinate 0, and where does that intersect this graph? So that's at this point 0, 4, and then 6, 4. The average rate of change here, again, is always represented by a line segment. Shrunk. So I'm going to come down here and I'm going to label this saying this is the average rate of change. I'm just going to say average rate is this line right here, which means graphically I should be able to grab that line, Command C, Command V, paste that line. This is the same line. I've made it red now. I should be able to drag that line somewhere and it will eventually be a tangent line. Let's see where it happens. Dragging that line, dragging that line. I don't know what to do there. If I keep dragging it, there's nowhere really, maybe right there at that spot 3, 1. But I don't know. What do you guys think about this problem? Should I leave it there? Are there no actual places that I can drag this? Where can I put that tangent line graphically?
Mm.
Should I put it at that spot 3, 1? Does that make sense? Is the slope at this, the instantaneous rate of change at 3, 1, is it this slope of 0? Come on, guys, you got to give me something. Take a yes. Just say yes or no. Can I put it right here? Is the slope at this instantaneous rate of change, is this point right here, the instantaneous rate of change, is the slope 0? Does that make sense to leave this tangent line? And then the tablet stops working again.
No,
No. Why not, Chris?
because it is not at 0.
It's not a 0. Okay. Can anyone else explain why this is not 0? Chris is right. You can't put it here. Andrea Teflon? I know Fiona has already spoken on this exact same type of question before, so I think she knows. Okay, Fiona, do you want to say it again?
This is just sharp corner.
Exactly. You can't put any instantaneous rates of change on sharp corners. It's not differentiable at those points. And if you think back, at the very beginning, I said, hey, oh, what happened there? Scroll up and scroll down, we'll fix it. If I look at the needs for MVT, it needs to be differentiable everywhere in that interval between A and B. And look, it's not differentiable everywhere in between A and B, so I can't put it there. And of course, the tablet's not gonna work again. So I'm gonna go ahead and type here that we can't put it there. Can't put the tangent line here. So in short, we can say for our answer, no. Because it's asking, does MVT guarantee that G prime C is equal to the average rate of change somewhere in that interval? And the answer is no. And then you can say why? Because we cannot use MVT since we have a sharp corner. And if you want to explain even more, that's enough, but you can say even more if you want, which is discontinuous. That's it. That's all of our notes. And we have 30 seconds left of class. I'll send out a text message with Aries communication on what the homework is. But that's all we've got, guys. It's probably going to be a mixture of paper assignment and Khan Academy, I'm guessing. I just need to take another peek at the homework before I actually make that call.